Hi, welcome to our next mini lecture on pre-calculus. So here we are doing the opposite of the activity last time. Last time we took an expression and wrote it as individual logarithm. Now we want to collect a bunch of logarithms and write the answer with just a single logarithm. So it says a single logarithm. That's the important clue there as to what we want to do. So let's see, we just apply the rules. First I open the parentheses, so I have 4 logarithm of w in base c, and then minus 8 logarithm of y in base c, and then 2 logarithm of z in base c. You could have also proceeded by interior of this parentheses first. Either way is fine. So next, you remember let me write the rule here. Logarithm of, say, a in base b times some uh, factor r here, that's same as logarithm of a to power of r in base b. Okay, so therefore simply becomes exponent of w, 8 exponent of y, and 2 exponent of z. So let's go ahead and write this, and then minus logarithm of y to power of 8 in base c, and logarithm of z squared in base c. Next, you remember the subtraction means a ratio, addition means multiplication. So I have logarithm. Now we are lucky that all the bases are the same. We'll deal with different bases later on, but if you have two logarithms subtracted from each other, remember logarithm of a minus logarithm of b, that was logarithm of a over b. Whatever the base happens to be, so long as it's all the same, we are okay. So this becomes w4 y8, and then logarithm of z squared in base c. Next, we have addition of two logarithms. Let's remind ourselves about that rule. We had logarithm of a plus logarithm of b, that was logarithm of a times b, so long as the bases are all the same. So what happens here is that we are going to have logarithm of w4 y8 z squared, all of it in base c. It's a lot nicer if we treat all the entries the same way. w4 z squared y8, it's the same thing. This quantity times this fraction, or that quantity times the numerator of that fraction divided by the denominator. So here is the expression that you have to enter here, and of course the base is just c. Now, important thing is not to go overboard. This logarithm of x minus 7, as we said, there is no simple rule for that. There's nothing you want to do here. You gotta wait until calculus 2 to see some fancy rule and the so-called Taylor series expansion and such. Right now there's nothing to do. We just have 5 is going to be exponent, 4 is going to be exponent of that, and the subtraction means, well, you're taking the ratio. Again, we are lucky that the base is all the same, so this is all equal to logarithm base 2 of, so 5 is the exponent of this entry, x minus 7 to power of 5. 4 is the exponent here, and then the subtraction, just as we said, means you're taking a ratio. Then one more thing to mention is sometimes you might have fractions. Remember, one way to handle a fraction is same as before. It's just that a number raised to the power of a fraction is going to be a radical, so a logarithm base 8 of w. If you multiply it by a half, this is same as logarithm of w to power of a half in base 8. You can just leave it like that. That's perfectly good. If you want to modify it, that's another way, is to write it as square root of w. So let's do this thing quickly. So this becomes an exponent, this becomes an exponent. Here, well, there's just a 1. These two are going to be numerator and this one is going to be denominator. Can you guess how is that going to go? Just like our first example. So we write the common base here, we draw a fraction, all the items that are added to each other, we take each raised to the power of its exponent, which is the quantity that was in front of the logarithm, z to power of 3. Any item that is subtracted comes in the denominator. Whatever coefficient you have in front of it comes in the exponent. No coefficient means there's a 1. If there was, say, 5 here, we'll have y to power of 5, and that would take care of that problem. So again, previous exercise we took expressions such as these and then we expanded it to this style. That was expansion. Now we are doing a reverse of that. We are collecting and writing as a single logarithm. So you want to be quick back and forth between these two. So clarify the coefficients, so multiply through. All the items that are added come in the numerator, each variable to the power of the quantity in front of the log. Each quantity that is subtracted is going to be in the denominator. So here we have minus logarithm of y, means y is in the denominator. Overall coefficient of that is 4 times 2, that's 8. So the exponent is 8. So as simple as that. Make sure you get 5 right in a row and you'll be all set. Okay, until next time, good luck and God bless.